Okay, guys, so today's Unit 6, Section 5 notes is on the fundamental theorem of algebra. And so the fundamental theorem of algebra says an nth degree polynomial has n roots. So basically what that means is whatever degree it is, that's how many roots it will have. The word multiplicity refers to the number of times the root crosses the x-axis, or is a zero of the function. You can have repeated zeros. Those are kind of like double roots. So basically like where it hits the x-axis and then goes back up, or hits the x-axis and goes back down. So if you look at A, and again, you can use Desmos to graph any of these, so make sure you can graph them on your own. But A is a quadratic function. Remember, a quadratic looks like a U shape. B would be a cubic function because we have x and then we have basically x squared, so that would be x to the third. And then C is a quartic function because we have x squared and then we have another x squared, so that's x to the fourth. So the first thing you wanted to do in these is to determine the degree of the polynomial. So A has a degree of 2, making it a quadratic. B has a degree of 3, making it a cubic. And C has a degree of 4, making it a quartic polynomial. And you can see the graph on Desmos if you want to draw those. Then you want to see where does it cross the x-axis. So if you look in A, you can see it crosses at -1 and +2. So those are our two zeros. You can also see it crosses the y-intercept. So its y-intercept is -2. And you see that marked there. For B, you can see it crosses the x-axis at -1, and it also crosses the x-axis at 0. So those are the two of those. -1 is one of those double roots, so it has a multiplicity of 2. That means that it hits -1 and it goes back down. So basically it doesn't cross the x-axis, but it is a 0. So it hits the x-axis and comes back down. So that's why you say a multiplicity of 2 there for -1. It basically just means -1 twice. The y-intercept is 0, 0. That's where it crosses the y-axis. If you look at C, it hits at -1 and at +2. Both of those are what we call double roots. They have a multiplicity of 2 because it goes down and hits -1 and comes back up. And then it goes down and hits +2 and comes back up. Another way of thinking of these is that it will hit the root from both sides instead of just going through the x-axis. So that's why those are multiplicities of 2. And then 1, 2, 3, 4 is where it crosses the y-axis. So you have a y-intercept of 0, 4. The last thing I want to talk about is end behavior. That means as x is going to -infinity, that's to the left, where is y going? And as x is going to +infinity, that's to the right, where is y going? Well, you can see in A, as x goes to the left, y is going to +infinity. And as x goes to the right, y is also going to be going to +infinity. And there's your answers for that. You can see in B, as x goes to the left, it's going to be going down to -infinity. And as x goes to the right, it's going to +infinity. So as x goes to -infinity, y goes to -infinity. And as x goes to +infinity, y also goes to infinity. If you look at C, as x goes to the left, you can see it will continue going up. So as x goes to -infinity, y will go to infinity. And also as x goes to the right, as x goes to +infinity, y will also go to +infinity as it keeps going up. D, E, and F. So you got 3 more down here. The last 3 for these notes. D is just x plus 1, which is just a linear function. E is x plus 1 squared, which is a quadratic function. And F is x plus 1 to the third, which is a cubic function. If you look at D, you can see that it crosses the x-axis one place. It crosses at -1. It has a y-intercept of 0, 1, so it crosses the y-axis at +1. And As x goes to negative infinity, which is to the left, you can see y would be going to negative infinity. And as x goes to the right to positive infinity, y is also going up to positive infinity. So those are your end behaviors. In E, it is a quadratic. You can see the U shape here. It's a quadratic function. It crosses the x-axis at -1, and that's a multiplicity of 2, meaning that it hits at -1 and goes back up. It crosses the y-axis. The y-intercept is 0, 1, so it crosses at +1. The end behavior as x goes to the left, so as x goes to negative infinity, y is going up to infinity. And as x goes to the right to positive infinity, y is also going up to infinity in both. The last one here, f, is a cubic function. You can see it crosses at -1, and that gives you a multiplicity of 3, meaning every function has to have has to have whatever its degree is, it has to have that many zeros. So if it only crosses at one place at -1, if that's the only place it crosses the x-axis, then that is all 3 of the zeros would be at -1. So what that means is it's x plus 1, x plus 1, and x plus 1. And if you set all those equal to 0, that would be -1 would be your answer 3 times. The y-intercept, where it crosses the y-axis, is 0, 1. And if you look at the graph, as x goes to the left to negative infinity, y will continue to go down to negative infinity. And as x goes to the right to positive infinity, y will continue to go up to positive infinity. And these are your notes and graphs today for polynomial functions and the fundamental theorem of algebra, which just says you have as many zeros as your degree of your function.